Good afternoon, everyone. We're here for the multi-threading with Qt talk. If this is not what you're looking for, then now would be a great time to exit, run away. I'm going to go over what we have with regards to multi-threading in Qt and some use cases and pitfalls to avoid. So let's get started. My name is João Abecasis. It's up there. João is a very common name in Portugal. It's unfortunately not so easy to pronounce for non-native speakers. If you get it as João, that's pretty okay. I come from Portugal, as I said. I'm a software engineer at Nokia Qt Development Frameworks. I work in the Oslo office in Norway, where I have lived for the past 1.5 years. We recently organized the development teams in Oslo across around domains, air, earth, fire, and water. I am a developer in the earth domain, where I am also the domain architect. The earth domain deals with the file system, networking, concurrency, the object model, event loops, and the container classes. So basically anything that interfaces to the operating system or to the programming language. And in Qt, I have worked on mostly or a lot on file and I/O. And lately, I've been playing with our concurrency classes. I've been playing with a new read-write lock algorithm that's supposed to be much faster than what we currently have, but unfortunately, my current implementation is very racy, and I'm still trying to figure out why or where. Probably a bug somewhere in the implementation. In the past, I have contributed to the Boost C++ libraries. Has anyone here used Boost? By show of hands, a lot of you. Has anyone of you used Boost together with Qt? Not so many. In Boost, I contributed mostly to Boost Spirit, the parsing and output generation library. I also contributed to the Fusion, tuples on steroids. I also worked on a open source project Saga, which is simple API for grid applications. It's developed at Louisiana State University, the Center for Computation and Technology there. This offers a common API for building distributed applications and tools frameworks. They currently have a generalized MapReduce system built on top of it, and various other applications that mostly focusing on research and scientific applications. So the agenda for this talk is I'll give a general overview of the multi-threading topic. Then I'll give a couple of examples of how we are using multi-threading inside Qt. And then we'll go a little bit more in depth into the multi-threading support that Qt provides. In the end, we'll have time for some questions and answers. If you have any questions along the presentation, just feel free to raise a hand and I'll try to answer as best as I can. So let's start with the general overview. And so what is multi-threading? Are any of you guys writing multi-threaded applications with Qt currently? Some of you? So you're all writing multi-threaded applications. Why are you here? So what is a thread? Multi-threading relates to threads, so multiple threads. What is a thread? A thread is basically a context of code execution. You give it some code. It has its own stack where stack objects where you can allocate objects on that stack, and it can have some thread-specific data. Threads share resources and address space in a single process. So why would you use multiple threads? What for? I mean, single-threaded is good enough for anyone. It's basically just more of the same. So in UI applications, in particular, you would use multiple threading if you want to maintain a responsive UI. If you want to maintain a responsive UI, you want to be reacting to user input at all times. You don't want the user to wait on what he wants to do now. Also, if you have some operation that you need to do or want to do, and it takes a long time for it to run, you don't want everything else in your application to be blocked waiting for that to happen. So typically, you would move that to some other thread and continue with your processing, hopefully doing some asynchronous stuff. Eventually, you'll get back to whatever that lengthy operation was doing and ask it, are you finished? Are you done there? Can I use the results? You can also use multiple threads to improve performance on multiple core hardware. But improving performance using multiple threads is tricky business. You need to have an algorithm that is parallelizable. So that is also one possibility for using multiple threads. When would you not want to use multiple threads? Well, even if you have multiple cores available in your hardware and resource constraints when you're running on batteries, you might not want to power up a second processor if your secondary thread is not so important. So you might want to consider that. Also, if you don't do multi-threaded programming, if you don't have to debug multi-threaded algorithms, it will save you a lot of headaches. Personal experience. So that was my overview on multi-threading. How are we using multi-threading inside Qt? We're currently not doing too much, but there's a couple of places where we are using secondary threads or more threads. File dialogues is one case where we use QFileSystem Watcher through QFileSystem model to monitor the directory or the folder that we are showing in the file dialog and check for changes in the file system, files that appear, files that disappear, so that we can show them immediately to the user or as soon as possible. The file dialog there needs to be responsive, and you don't want to be querying the file system all the time while you're processing the user input. So QFileDialog uses QThread for that. QHost info lookup host is a function to look up host names, resolve them through DNS queries. This goes through the network. And in some operating systems, at least, it's a blocking call. It takes some time. You may have to wait for a timeout from the network before you can move forward. So doing this in the background thread allows us to queue up a lot of DNS lookups and get back to them later when they are available. This is using currently a QThread pool so that we can do multiple queries on the network, and you can also cancel them if they haven't been resolved yet, the lookup requests. Qt Creator is not exactly inside Qt, but it has it's a good example of using multiple threads in a graphical application. It freaking uses everything. QThread, QThread pool, Qt concurrent, you name it. It does this to provide syntax highlighting. You don't want to, I mean, what kind of experience would it be if every time you needed to update the colors in your code, you'd have to wait a couple of seconds for Qt Creator to finish doing what it does? Code completion, if it's not immediate, it's not good. Also, builds and you will see a lot of progress bars on the side whenever Qt Creator is doing something in the background. And then you know it's using multiple threads. So let's look at what we have in Qt to support multiple threading. This is just a very simple hello world. Also to say hi to you guys. I'm not going to run it. This is a single-threaded application, unless something else happens. But how do you turn this into a multiple-threaded application? Or no, let's leave that for later. So in a single-threaded application, you have a process. You have your process is a thread, or your thread is a process. But a process can have multiple threads. In the application I just showed you, you have basically just you have one thread, and it's running an event loop. You can have multiple threads, and you can have a thread pool with multiple threads that manages multiple threads, and that will use QRunnable, but we'll get back to that. So in the context of multiple threading, QProcess can also give you some sort of parallelism, although in reality it's not a thread. A separate process includes a thread. So the most basic or the most simple way of starting to do multiple threading is actually to fire off a process in the background to do something. This is very coarse-grained. You don't get a lot of control. But it's also very nice in terms of data sharing and synchronization if you don't need it. If you already have a process that does something for you, well, then just fire it off, let it be, and you'll get the result eventually. If you actually need sharing and synchronization, then this may become more expensive in QProcess when using a QProcess. So let's look at real threads. All you need to do to start using multiple threads, create a QThread object, run its start function, and then eventually, when you're done with the thread object, call quit and wait for it to actually exit. Not very useful as like that. It would be expected that somewhere in between you would actually do something to make use of that thread, otherwise it will be just idling in the event loop. So, taking something similar to the example, to the single thread example that we had before, I just added there a QThread, started it. I have a push button that is connected to the quit slot. I start my application. It basically does nothing. One thing to note that is important here is when using QThread is whether or not I actually ask for the thread to quit, I need to wait for it to exit. And this is something you should not forget when you're using QThread. If you don't wait for it to exit, when your application exits, you'll get a crash, segmentation fault or something, because the thread had not exited properly. You also need to actually tell it to quit running the event loop. So I'll just close that. It's a useless piece of code. So QThread, it's actually a thread. It offers you an event loop, and it gives you a place to connect signals and slots, or to have objects emitting signals and running slots connected to other signals. So let's look at another example, a little bit more useful, but still. I have here one class that defines no, this is going wrong. Okay, so I have a lengthy operation, which could be anything you like. In this case, my lengthy operation is actually a nanosleep of 750 milliseconds. And what I do is I encapsulated it into a queue object, just so that I could get a started and a done signal. In this case, I can also emit some progress while I'm at it. But in reality, this could be any operation that takes some time, any expensive computation that you have to do. And then I have my UI, which is basically a text edit, a button, and a progress bar that tells me how that operation is doing. I put everything on the screen. I create my lengthy operation. I connect some signals to it. When I click it, the operation starts, and the progress of that operation updates the progress bar. I show it, and I run the application. So let's see what that looks like. Now, of course, since this is in a single thread, what do you expect to happen when I click? The progress bar updates. I'm calling the update function, but at some point, my window manager grays out the window saying it's unresponsive. It's not replying to input. And since I clicked multiple times, it will go on doing its stuff. I also press some keys, and this will only the application will only get to them when it's actually finished doing the lengthy operation. So to make this multi-threaded, to make this more responsive, it's actually really simple. And we'll do that right now. We'll create a background thread, which is background just because I decided to call it background. There's nothing special about it being background. I move my object to thread. Everything else stays the same. I just need to do my thread cleanup here. And all of a sudden, well, why is it not updating? Did I forget something? I forgot to start the thread, of course. So it's a pretty useless thread if it's not even running. So same thing as before. Now my UI gets responsive. Once you get to this point, then you can really start exploring more complex setups. I mean, why have a single operation? Why have a single operation, a single lengthy operation running when you can have multiple of them and just report the progress for all of them at once? Oh, I would show you the scroll bar moving, but So multiple threading doesn't need to be hard. When you're using signals and slots, you can basically just throw your objects into a separate thread and have it run the slots it's connected to there. Another option that you have is to use QRunnable. There, you wouldn't be managing the thread yourself, and instead of having a Q object for your lengthy operation, you would derive from QRunnable and override the run function. So QRunnable manages the threads for you. You just need to remember at the end to wait for all the threads to be done. So how many threads should you be running once you start going multi-threaded, or how many processes? Does anyone want to take a guess? Well, there is no single answer. Of course, it depends. Depends on the type of operations you are doing in the background. Depends on your hardware. The answer could be once per core that you have, but it really depends on what you are doing. If you are doing CPU-intensive computations, then yes, once per thread, one thread per core could be appropriate. If you're going through the network, if you're doing file I/O, then one thread per core is probably not the best option. If you have multiple network cards, you would at least want one thread per network card. But the thing is, going through the network, through I/O doesn't really load your CPUs. So if you're going for maximizing your throughput or maximizing what you can do, then you really need to go over what the operations you are doing look like, and consider, maybe measure the load on the CPUs. Maybe measuring would be the best option. So besides QThread and QRunnable, which in a way are still offering an interface to threads, you can use Qt concurrent, where instead of focusing on the how, you're focusing on the how, you're focusing on the what. Qt concurrent offers you a functional interface to multi-threaded programming. There are three main concepts that we currently support in Qt concurrent. Filter, which takes a list of objects and returns you this similar list of objects with some of those objects filtered out. So in this slide, I actually have a typo, because filter should take a T star, many T's, and return many T's as well, although the number might change. Reduce will take many objects and return you a different type of object. It's also similar to what std accumulate does. It's like accumulation. And map will take one type and map it to some other type. One use case that you could use with map reduce with this infrastructure filter reduce map is the map reduce abstraction. One example of using it would be to go through the files in some directory, the Qt source tree or something, find the CPP files, and read them and count the words that appear there. Where the filter would, you would start with the full list of files. You would filter them to the CPP files. You would map the CPP files to lists of words, and in the end, you would reduce them all to a single list count. So yay, multiple threads: QProcess, QThread, QThreadable, QRunnable. Multiple thread just gets you started. and gets you headed towards the headaches of multiple-threaded programming. So what happens once you have all your threads running? If you're just using signals and slots to communicate between them, then that's great. You could be basically done now. But most of the time, you will want to share data between threads that maybe you want to have a single source of the data. Maybe you can't just send the data around in signals and slots. So how does one go from having multiple threads to having multiple threads that actually cooperate on doing something? Qt offers a couple of classes to support this. QMutex being one of them. It offers one-at-a-time access, so all your threads will be serialized when they try to access the QMutex. Mutex stands for mutual exclusion. And yeah, that's what you would use a QMutex with a QMutex locker that handles locking and locking in a given scope. So what do you have to watch out for when you are using QMutex? When you have a mutex, it stands for something, and this is what you always have to consider. What does my mutex stand for? It is holding a lock. It holds a lock on some data or on some resource, and the scope for that mutex, when you're writing your application, needs to be clearly defined. Maybe it's protecting the access to a couple of variables. Maybe it's protecting the access to a whole object. Maybe it's protecting the access to a database connection or something else. So that's the scope of what it protects. Besides the scope of what it protects, whenever you are using a QMutex, you have to beware of the scope where you hold that mutex locked. You would want that scope to be as limited as possible, and you would want to have full control of the scope, of what runs within that scope, so that you can avoid things like deadlocks. So what is a deadlock? A deadlock happens when you have multiple QMutexes. First thread locks the mutex 1, second thread locks mutex 2, and then thread 1 wants to access mutex 2. And look, lo and behold, thread 2 is holding it, so I'll just wait. In the meantime, thread 2 is still holding the second mutex, and it wants to access the data protected by mutex 1, so it tries to lock it. And all of a sudden, your two threads are locked waiting for one another, and none of them are going to give in. So how do you code around this? Well, basically by reducing the scope of where you hold the locks, or by forcing an order on how multiple locks are acquired. You should also, as I said, you need to be always in full control of where the scope where the mutex is locked. If you always know where the mutex is locked, it's easier for you to debug and find out, okay, I'm holding the first lock while I'm accessing the second one. So I need to either unlock the first one, or I need to have the other thread lock both mutexes at once before this deadlock happens. Another thing to watch out for when you are reducing the scope of the lock, is that maybe you're doing a lot of things in this function or while you're holding a lock, and that you would think, okay, so I only need to access the data here and there, and you lock it in one place and lock it, then you do something else, and then you lock the mutex again, and read the same or access the same data and unlock the mutex. Every time you lock or every time you unlock a mutex, the data or the resource that it protects can change, and you have to consider this when you're using a mutex to protect your data. Another type of lock that we have is QRead-write locks. It's similar to QMutex, only it allows multiple readers to share the lock at once, and only a single writer. So you would use QRead-write lock when you have maybe a list of data that's updated infrequently, or you're going to access it a lot of times, and maybe it's updated infrequently. So you don't want the readers to be waiting if they are not touching in any way changing the data. So they can all just go through. When the writer comes and tries to lock it, it will notice there are readers, and it will wait for those readers that currently have the lock to finish before it acquires the lock. Once the writer goes through, no reader can go through until the writer is done, and subsequent writers must also wait. The same as QMutex, once you acquire a writer lock, you need to watch out for deadlocks. The read-write lock is basically a QMutex when it's in write mode. When it's in read mode, it shouldn't be possible for you to get deadlocks. So when you're using QMutex and QRead-write lock for protecting your data or your resources in general, what is the risk? The risk is if you're locking them too much, you might end up having all your threads serializing access to the resources. And then instead of multiple threads, you fall into a single thread again where all threads are just waiting for one another. So that goes back to reducing the scope where you hold your locks. Also, another thing that you can consider is maybe this data changes infrequently, or maybe for the duration of your thread, you don't need to look at changes. Maybe your thread just does it's a single purpose thread, does something, it's done with it. It can read it can access the resource a single time, store that result in local storage, and use that until it's done. And then you also reduce the scope of your mutexes. So qthread storage offers you per thread data. It only stores pointers, but you can allocate any object you like and give it the pointer. The qthread storage will take ownership of that data and will delete it for you when it's done, or when the thread is done. You can also use qthread storage when you have some expensive computation that you don't want to do all the time. When you're doing lazy initialization of some data, you want to avoid race conditions between threads, then you would use a qthread storage, and you just assume that each thread will do its own lengthy computation so that you don't need to consider synchronization across multiple threads trying to initialize data at the same time. We recently had an issue in QUUID that it was using a random number generator, but it was using a really good random number generator. So it kind of destroyed the purpose of QUID. So what we did was started using a truly random number generator on POSIX platforms, and using /staff/random. And for this, we were reading from that device with a Q file, and opening a file and closing it every single time you wanted the UUID. So this showed up in our benchmarks a huge performance regression. And what we did to fix it was to keep the file open at all times. And to avoid having to synchronize this file across threads, then we just open a file per thread and keep it open for the duration of that thread. And that at least improved the performance regression a lot. So once you're using threads and thread pools or concurrent, you're using mutexes, you're using read-write locks and thread local storage. Where do you go from here? These are just some common primitives, but you might want to do more elaborate stuff, like write your own concurrent algorithms, maybe write your own concurrent data structures to do more fancy synchronization and parallelism. Qt offers some building blocks for doing this. We have the semaphore and the wait condition synchronization primitives. QSemaphore is actually a counting semaphore. You can see it as a QMutex, where instead of a single accessor to your protected resource, you can have multiple accesses. So each thread going in will reduce the current available count by 1. And when that goes to 0, everyone else will wait for resources to become available. But it's also a synchronization primitive that you can use it, for instance, to have multiple threads start doing something all at once, where you release multiple objects. You have all your threads waiting to acquire one count, and you release it from some other thread, and all your threads will start. I have been using this recently to test our contended lock performance. The algorithm doesn't use a single Q semaphore, but uses 4 semaphores inside a Q benchmark loop to synchronize start and ending of the multiple threads doing contended locking or unlocking or something. QWait condition is another synchronization primitive. You use it together with the mutex. The mutex here actually provides you atomicity. It's another general purpose synchronization mechanism. One instance of something similar to wait condition is when you do a QThread wait. You're actually waiting for the thread to signal to tell you, you can go now, I am done. So you would use this in your code to when you have when you have one thread doing some processing and one thread that maybe asked for this processing and went do other stuff, but at some point it will need to actually get the results from that processing. So maybe the processing thread can signal, okay, I'm done. And when I get to that point, I'll just check, are you done? No, then I will wait for you to be done. And your waiting thread will be woken up when the processing thread actually finishes. Besides the synchronization primitives, we have atomic operations, QAtomic int, QAtomic pointer offer atomic operations on integers and pointers. The operations we currently offer are test and set. Does this value correspond to some known value? If yes, set it, otherwise fail. So that you don't end up in a case where you are checking a condition, and then when you are taking the result of that check into account, the condition has already changed. So that's when you need atomic operations. We use it, for instance, in ref counts for atomic. All our containers have an atomic reference count that is incremented by each watcher or each copy of the container. QAtomic pointer offers similar things, but for pointers. Oh, I was going through what the operations we offer. So test and set. We also offer fetch and set. Get me the current value and set a new one. And test, no, fetch and set, test and set. I guess those are the ones. And then we offer the same thing for with multiple guarantees in terms of memory barriers. So, as far as slides go, that's what I had to show you. If you want to make some questions, or there's a...
Hello.
Hello.
Are there any plans to support the new C++ OX threading API, or at least have some bridging code to that new API?
Well, C++ OX isn't out yet, and the only threading implementation that I know of is actually by Anthony Williams in Just Software. I would like us to interface more with the STL and whatever STD, whatever the new standard is going to offer. We have started giving adding some support for features in C++ OX in Qt, but we have no current plans with regards to STD thread. But we do support you using other threading libraries to do your threading, and maybe even running event loops on those threads.
Actually, I have two questions.
Okay.
Earlier you spoke about QMutex, that you should lock and unlock as soon as possible, but does QMutex locker help prevent deadlocks?
Not by itself, no.
Okay. And the second question is, if you create, for example, a mobile application that uses a thread that runs forever because you have to check some data on some web service, does Qt help have something that can save the battery, not drain the battery at all, or what can we as developers do to prevent that?
So I guess you would have to signal that thread to stop processing. You would have to react to events from the mobile, from the phone, or from the embedded hardware that you have. The sensors, is it like in the phone when the screen goes off, maybe you don't want to, you're not showing anything to the user. So I think it is possible currently to do that, but you would have to be the one reacting. Your code would have to be the one reacting to the user input and deciding whether or not to continue doing the background processing.
But what, for example, the users should have the screen turned off and in the pocket, and then actually to notify them whenever some update happens or something.
Yeah, but then again, that goes back to, you would have to find the events that are meaningful to your case and see how you should react to those.
My questions are more related to not multi-threading, but maybe multi-application. For example, well known that a lot of security access from one application to another application provided by operation system. But maybe Qt has something in this area too. For example, to protect one application to grab some data from other application. Something this.
We do have, there's QSystem semaphore, which is basically a semaphore that works at the OS level. So it allows you to synchronize across processes and not just in a single process. And there's you can also use shared memory.
But any permissions access something this API provided by Qt? No specific or something exists?
Sorry, I didn't understand the question.
Question is about have Qt personally have something API which provides some protection, not operation system.
Well, QSystem Semaphore is a Qt API. It's based on what the operating system provides, and you can use that even across non-Qt applications. There's a question there in the corner, Ralph.
Hello. I have several questions. The first, I want go further in detail about event handling in threads, and when a thread has their own event loop and no events must be processed, are there any mechanism to suspend the thread, or is there any influence to the scheduling mechanism, to the operating system, or anything that this thread is not scheduled so often?
So when you start the thread, you can give it the priority. So that would be one case. But if you actually want to stop the thread processing for a while, and this is not, you might want to change how often this thread is processing, then maybe you could send it an event that you catch and wait for something else to happen using the wait condition, and then the thread will sleep until you wake it up.
Okay, thank you. Next question. Is there any better way to share data between threads? One option could be to have any shared object or global variables or anything like this, and use mutexes to control the access. Or on the other side, we could use signals and slots to transport data between different threads. Are there any better options?
Well, you don't need to use global data if your thread knows about some data, some local data. So you could maybe, it depends. It really depends on how you write your application. But what kind of other options were you thinking of?
Yeah, if I write a thread that access shared data,
yes,
then it's not so much portable. It's if I write a thread that communicates only via signals and slots, it's a design thing, but it's more a portable version.
But using QMutex and the shared data is just as portable as using signals and slots. No?
Okay. Next question. In general design question, if I plan an application using multiple threads, in the most examples, small pieces of code, small functions put in threads and executed as a separate thread. Is it, if I plan an application that has different parts that are mostly completely independent from each other, could it also be a good idea to put each of these parts in separate threads that running all the time? Or is it not a good idea to do this? Better process all the different parts in events and only put small pieces of code in small functions?
It depends on what you're trying to accomplish. I mean, if you have a lot of a lot of things that have no connection to one another, then yes, maybe it's better to have them in separate threads or even in separate processes and just have them run completely independent. I mean, that's a good thing, especially in multiple threading, if the multiple threads are doing completely independent things. But then you have to look at the end goal that you are trying to achieve, and where is this application going to run? Are some threads higher priority than others? Maybe you don't need to have separate threads for each of them. Maybe you can use a thread pool and just have them using QRunnables, and you queue the tasks that you have and let thread pool schedule them as the threads become available. That could be a very good option.
Okay, thank you.
There's a question there.
Hi. This concurrent is presently disabled in Symbian platform. What's the reason for it, and when will it be available?
I don't have a timeline for when it will be available. It's currently disabled because of compiler support. So we had some issues getting it compiled on Symbian, and so we decided to disable it. But we are working on getting it supported.
Does Qt support locking more than one mutex at the same time?
Sorry? Can you repeat?
Does Qt support
Yes.
locking
More
than one mutex at the same time?
I honestly don't remember that we have support for that. Like an algorithm, a general algorithm to lock algorithms, to lock mutexes. Is that your question? Yeah. I don't think we have that. There's a question there in the back, in the middle.
Yep.
I had the question, what tools are there to find deadlocks, to find, possible problems with the threads I have programmed? Are there any tools that are provided to analyze my program?
Not by Qt directly. And this is how I usually do debugging of race conditions and deadlocks and whatever. And it's the only way that I know that actually works, is to stare at the code for hours until your head aches and you finally see the solution. Basically, when you do threaded programming, you have to prove that the code is right, instead of waiting to find a debug statement telling you it's wrong. Because when it's wrong, when you get the race condition, you might actually get the result or the bad results out of that race condition much further away from where it happened.
In the example you showed, you use move to thread to move the processing of the event loop to a separate thread. Are there any specific concerns about moving file descriptors or other types of resources to a thread?
No. So the move to thread is only about signals and slots processing. If you open a file descriptor, it's automatically available for all threads to use. If you have an integer file descriptor number, or is that not what you were asking?
No, I think it does answer the question. And the second part of the question was, when you have, let's say you're moving the event loop of a fairly complex object to a thread, are the child objects automatically also, is the event handling for the children also moved to the thread implicitly or not?
Now that you ask, I don't know the answer. I think so, but I would have to look it up before giving you a definitive answer. So does anyone want to look at more code? Oh, there's still a question here at the front.
Thank you. Would you like to comment about using QSQL across threads?
I don't know anything about QSQL actually.
Okay.
So if you guys want to look at code, I can maybe show this.
Could you please tell us the difference between auto connection and Qt connection? Because how the other thread, how we post events to the other thread, and the other thread knows, oh, this was a signal, and now it's an event, and I think it has to do with these two flags.
Yep. So when I showed you this, I'll just run it again because I like it. When I showed you this example before, where I'm moving the background processing to separate thread and having even multiple threads running, the code is actually very similar to the first one, only I had to add some more code to track each progress bar. And one of the things the progress tracker, my progress tracker does is invoke the operation as a queued connection. So what is a queued connection? Queued connection means it's not immediate. It will go through the event loop, and eventually the object will get it. So if I was doing a queue object connect, the queued connection would be automatically a queued connection if the objects are in separate threads. When you do invoke method, then you would want to do queued connection explicitly. And so that's the basic difference. Whether the call happens directly at the moment you emit the signal, or whether the call will go through the event loop and be called. In this case, by going through the queued connection, by having a background thread doing my lengthy operation, I disconnect the lengthy operation from the UI. By using a queued connection to update the progress bar, I disconnect also the update from the lengthy operation. So they don't have to wait for each other to happen. Does that answer your question?
Hi. I was wondering whether the multi-threading support in Qt currently is more or less finished, or whether new things are to be expected in the future. Is there still room for improvement? For instance, supporting detection of erroneous conditions?
I'm sorry, can you repeat the question? I lost.
Will Qt concurrency support further evolve in the future, for instance, to resolve or to detect errors? Will it become more easy to exploit multi-core hardware, or is this the point where you expect?
I certainly hope that we evolve. I see a lot of room for improvement and supporting more threading models, maybe.
Is anything in the pipeline?
We're currently working on improving the performance of what we already have there, but there's nothing that is actively being worked on in terms of new features now. Okay. So, thank you all for listening, and if you want to look at threaded code or something, just find me in the hallways. I'll be happy to show.